So we have been looking at chemical reactions for the first part of this chapter, and specifically we looked at combustion quite a bit, but then also looked at balancing equations. So every reaction, chemical reaction, can be classified into 5 basic types. So synthesis, decomposition, single displacement, double displacement, or combustion. So the purpose of this is for you to identify or recognize what type of reaction is occurring based on the chemical reaction formula that's given to you. So the first one, synthesis, sometimes it's called combination reaction, but this is when 2 or more substances combine to form a new single substance. Okay, so the general form of this is A plus B yields AB. Okay, so it might be like H2 plus O2 yields H2O. Okay, so we're taking 2 separate molecules and combining them together to get one molecule or one compound. Okay, this occurs frequently to form an oxide where an element reacts with oxygen. Okay, decomposition, on the other hand, is kind of the opposite of synthesis. So a compound is actually going to break down into 2 or more simpler substances. Okay, so the general form is that we have a compound AB and it's going to split into A and B like molecules. Okay, so most decomposition requires an input of energy in the form of heat, light, or electricity. Okay, so there has to be some type of energy input into it in order to kind of break apart those atoms from each other. And so pay attention to the direction of the arrow. It determines the reactants and the products. For the most part, you're going to find that the reactants are going to be on the left side and the products are going to be on the right side. But sometimes you will see this, like if you go on to take college courses and stuff, they'll switch them. And the only indication is the arrow. So just be careful whenever doing these types of problems. Watch the arrow, because if the arrow were going in the opposite direction here, this would actually be a decomposition because we're going from a whole to pieces. Okay. The next 2, single displacement and double displacement. For single displacement, one element replaces a similar element in that compound. So what that means is like a metal is going to switch with a metal, or a non-metal will switch with a non-metal. Okay, so the form of this is we have our element A plus the compound BC. Okay, so element B and C are bound together. Right, and then through single displacement, the A and the B are going to switch. Okay, having that single displacement. So now A is bonded with C and then B is on its own. Okay, and we assume that A and B are either both metals or they're both non-metals. Double displacement reactions, a positive and negative ions of 2 ionic compounds exchange places to form new compounds. So we had A bonded with B and C bonded with D, but whenever they break apart and rearrange, now I have A bonded with D and C bonded with B. Okay, so remember, ionic bonds generally form between metals and nonmetals. Okay, so we'll have our metal, nonmetal, metal, nonmetal. Okay, and then they're going to rearrange to have metal, nonmetal, metal, nonmetal. All right, and then combustion, like I said, was one that we've been talking about for the first half of this chapter. So a substance is going to react with oxygen and it's going to release energy in the form of light and heat. Okay, most of the time this substance is going to be a hydrocarbon, and that's what I would like you to consider whenever doing your homework, that a chemical reaction is only considered combustion when a hydrocarbon is involved. Okay, so remember, a hydrocarbon is going to have carbon and hydrogen as one of the molecules that's going to be reacting with oxygen in order to produce CO2 and water, or if it's incomplete combustion, to produce carbon monoxide, and water. Okay, So here, this equation, we have hydrogen and oxygen yielding water. Okay, so this, like the example I said, this could be considered synthesis. For your homework, I would prefer that you would mark it as synthesis. Because this is not a hydrocarbon, don't consider this combustion for your actual homework, okay? But technically, because it is reacting with oxygen, it could be classified at that. But more accurately, I would classify this one as a synthesis reaction, and then this one, because we have the hydrocarbon mixing with the oxygen, producing the carbon dioxide and water, this would be considered combustion. Okay, and I even made a note of that. For homework, only consider combustion as the type of reaction if it involves a hydrocarbon and oxygen. All right, so going on to the practice problems, this first one we have that hydrogen and oxygen is going to yield H2O. Okay, so we have two separate molecules, and then they're going to combine to create one molecule, so this is synthesis. Okay, for the next one, I have Na2CO3, so I have one compound here, okay, and that's going to yield Na2O and CO2, okay, it's two separate compounds, so it has broken down from 1 to 2 simpler parts, so this would be decomposition. Right, for the next one, I have aluminum, and then I have PbNO3, 2, and then you'll see it yields PbAlNO3, 3. Okay, so you'll notice that what happens is the aluminum and lead switch places. Okay, so only one thing switched, so this would be single displacement. For the next one, I have FeHSO4, and then it's going to yield FeSO4H2. Okay, so my H and my Fe switch in the products, so there was a single thing that switched, so that would be single displacement as well. Okay, and then this last one, I have CaOH2 plus H3PO4, and that's going to yield Ca3PO42. Okay, so the OH switched with this PO4, and then for this one, for the water, okay, the OH bonded with the O, and so there were two things that were being switched, so this would be double displacement.